The FAA just deployed AI to prevent plane crashes, and it's already changing how airports operate. Plus, Google revealed a breakthrough in making diffusion models interpretable, and Microsoft found a massive blind spot in current AI code generation. No BS AI briefing brought to you by Proactive AI. Welcome back. I'm your host Vikash, and this is where builders get straightforward AI news without the fluff. Alright, let's dive into some really high signal items for builders this week. First up, Google DeepMind just released DiffusionGemma 26B A4B, an open source text diffusion model. Now, what's really interesting here is its interpretable token bottleneck. In plain English, DeepMind is tackling one of the biggest challenges in AI, understanding how these powerful models make their decisions. They're reducing the opaque serial depth of these models, getting it closer to how Gemma 4 operates, and even documenting some fascinating diffusion phenomena like non-chronological reasoning and token smearing. For builders, this is a big deal because it brings transparency and debuggability to diffusion-based LLMs. Imagine being able to see why your model generated a certain piece of text or image rather than it being a complete black box. And because it's open source, we can all start experimenting directly with these interpretability methods. This isn't just academic, it's about building more reliable, trustworthy AI products, especially as these models become more integrated into our core offerings. Next, Microsoft's new Multi-LCB benchmark just exposed a widespread Python overfitting problem in code generation models. We've been seeing amazing code generation, right? But Multi-LCB, which extends their existing live code bench to include 12 different languages, reveals that many of these models perform brilliantly in Python but fall flat in others. It's basically showing extensive Python overfitting and a lot of language-specific data contamination. This benchmark is compatible with LCB's existing contamination controls and updates alongside it, which is crucial for reliability. So, why does this matter for you, the builder? Well, if your product relies on code generation in languages like Go, Rust, or C++, you might be getting a skewed picture of your model's real capabilities. This benchmark enables fair multi-language evaluation for code tools, helping you make informed product choices that go beyond just Python-centric performance. It's time to test your tools in the real language environments your users actually use. Don't assume Python performance translates. Also this week, Elastic, the company behind Elasticsearch, agreed to acquire DeductiveAI for up to $85 million. DeductiveAI specializes in adding AI-powered site reliability engineering, or SRE, to observability platforms, specifically for automated bug detection and resolution. This acquisition signals a clear trend. AI capabilities are rapidly consolidating into core infrastructure tools and incident response workflows. So, what's the builder takeaway here? Expect AI-powered debugging and incident response to become standard features in observability stacks very soon. This validates the growing demand for AI SRE solutions. If you're building in this space or even just using these tools, you need to be thinking about how AI will automate more of your operational headaches, from detecting anomalies to even suggesting fixes. It's a huge market signal. AI isn't just for front-end features anymore, it's becoming foundational. Then, on the policy front, the JAWBONE Act was just introduced by Senators Ted Cruz and Ron Wyden. This act aims to create a federal cause of action against government officials who coerce companies, including AI providers, into removing lawful speech. This is significant, isn't it, as builders in the AI space, especially those working on open models or platforms that facilitate content creation and sharing, we're constantly navigating complex issues around content moderation and censorship. This act offers a clearer legal framework for us, protecting builders of open or neutral AI platforms from undue political pressure to censor content. It's about ensuring that the tools we build can operate freely within the bounds of the law without constant fear of government overreach. It's a crucial step for the long-term health of an open AI ecosystem, providing a potential shield against arbitrary demands. And finally, something truly impactful. The FAA has officially deployed Palantir Foundry AI to help prevent runway incursions. This is a big one. They've partnered with Palantir to synthesize vast amounts of data, incident reports, weather patterns, radar data, and more, all to predict and ultimately prevent dangerous runway incursions. What's even more impressive is that this isn't just a pilot project, it's led to real operational changes. For instance, based on Foundry's analysis, parallel landings have been banned at San Francisco International Airport. This is a large scale, safety critical AI deployment with measurable real world impact. For founders and product leaders, this story screams value. It shows that the true power of AI often comes from intelligent data integration and actionable insights rather than just a novel algorithm. It's about solving hard, real world problems with clear benefits. Let's do a deep dive into that last story. The FAA's deployment of Palantir Foundry AI to prevent runway incursions. What happened here is incredibly concrete and a fantastic example of applied AI. The Federal Aviation Administration, a massive government agency responsible for air safety, has teamed up with Palantir to implement an AI system within Palantir's Foundry platform. This system is designed to crunch huge fragmented data sets, everything from historical incident reports to real-time weather and radar data. Its goal is to identify patterns and predict when and where a runway incursion, which is essentially an unauthorized presence on an airport runway, is likely to occur. And it's not just generating reports, it's already led to tangible operational changes. For instance, based on Foundry's analysis, parallel landings have been banned at San Francisco International Airport. That's a real measured impact. Why does this matter right now? Well, for too long, AI has been stuck in a cycle of hype, research papers, and cool demos. But this is a classic example of AI moving from theoretical promise to safety critical infrastructure. It's a clear signal that mature data driven AI solutions are no longer just for tech giants or ad targeting. When a public safety agency like the FAA trusts AI to make decisions that directly impact human lives, it means the technology has crossed a significant threshold. It's about leveraging existing data, often messy and siloed, to unlock predictive power and ultimately improve safety. This shifts the conversation from can AI do this to how quickly and effectively can we deploy AI to solve our most critical problems. It demonstrates that AI, when implemented thoughtfully, can have profound operational effects. So, who should really care about this? Founders, absolutely. This is a blueprint for building high impact products. Find a complex, data rich problem with fragmented information, integrate that data, apply AI to find patterns, and then enable truly actionable insights that drive real world change. Product managers, take note. The success here wasn't about the newest neural network architecture. It was fundamentally about effective data engineering, reliable execution, and user friendly insights. Engineering leaders, this highlights the critical importance of robust data pipelines, model reliability, and explainability in mission critical applications. Even indie hackers should look at this and think about how they can apply similar principles to smaller niche problems where data is scattered but valuable. It's a story about solving a serious problem with existing, proven technological approaches. How I think about it as a builder is this. Stop chasing the shiny new model for a moment. Look for areas in your product or business where critical decisions are being made based on incomplete, siloed, or lagging information. Think of it like a jigsaw puzzle where half the pieces are under the couch and the other half are scattered across different tables. The FA's success wasn't primarily about creating a brand new cutting edge AI piece. It was about finding all those scattered pieces, putting them together efficiently, and then letting the AI see the complete picture and surface those hidden connections. The mental model here is data integration before algorithmic sophistication. Your biggest opportunity might not be in training a massive LLM from scratch, but in consolidating and making sense of the data you already have to power simpler, targeted AI solutions that deliver measurable, undeniable value. It's about bringing disparate data into conversation. My no BS take on this is real, this isn't hype. The FAA deployment of Foundry AI demonstrates that the true immediate value of applied AI often lies in its ability to synthesize disparate data sources into actionable intelligence, especially for risk mitigation. It's about unlocking latent value in existing data to solve hard, costly problems, not magic. And that's a powerful lesson for all of us. If you want one practical takeaway from today's episode, especially inspired by that FAA story of data integration driving real world impact, here it is. Map 3-5 fragmented data sources in your product or team and sketch a single integrated view to unlock new AI workflows in under 60 minutes. Here's how to try it in under an hour. 1. Identify the fragmentation hotspot. Pick a specific problem area in your product or team where different pieces of information are currently scattered across various tools. Maybe it's customer support tickets in one system, CRM data in another, product usage logs in a third, and marketing campaign performance in a fourth. Identify 3 to 5 distinct sources that, if combined, could tell a much richer story. 2. Sedu. Sketch the integration pathways. Grab a whiteboard, a large piece of paper, or even a digital tool like Miro. Draw simple boxes for each of your identified data sources. Then draw lines and arrows connecting them, imagining how they could flow into a central AI brain that can see all this information simultaneously. Don't worry about the technical implementation yet, just visualize the logical connections. 3. Brainstorm AI-powered questions and workflows. Now, with that integrated view, brainstorm 2-3 specific high-impact AI-powered workflows or questions you could answer that are impossible today. Could you predict user churn with higher accuracy? Could you automate a more personalized customer service response? Could you flag potential issues in your product before users even report them? Focus on what insights or actions become possible. Why this specific experiment is worth your time right now? Because, like the FA discovered, many of us are sitting on gold mines of data, but they're buried in separate silos. Unifying them, even conceptually at first, is the quickest, lowest cost path to identifying high impact AI applications without needing to train a single new model. It helps you clearly see where the real immediate value lies before you invest heavy engineering resources. It's about identifying the core data-driven problem first, not just applying AI for AI's sake. That's it for today's No BS AI briefing. If this helped, follow the show in your podcast app and share it with one builder you know. And if you've got questions or topics you want covered, connect with me on LinkedIn and send them over. See you in the next briefing.